ICP, yes or no? Now I've been asked if my sensor need ICP supply. I don't know. It doesn't say. Does it need ICP? Do I need ICP? What is ICP good for? And how can I use it correctly? IEPE, ICP, CCLD, Isotron, DeltaTron, each company has its own name, but the idea is always the same. The signal generated by the sensor is a tiny change in charge or voltage. In order to record this, you first must amplify the signal. In the past, an oscilloscope was used to analyze the signal. I can show you. First, the sensor signal goes through an amplifier, which is built in this oscilloscope to cover and strengthen the signal so we can display it. One of these devices can handle 1 or 2 channels. Sorry, this is too big. Nowadays, the amplifiers have become much smaller, tiny. They are already integrated into the sensor. That small they have become. That's why ICP, Integrated Circuit Piezoelectric, is in there. Now it is less sensitive to external interference because the integrated amplifier sends a sensitive source signal to an impedance converter, which then transmitted to the line with low output impedance. Strengthened in this way, the signal is insensitive to interference even on longer lines. And that is easy to measure even when it's transmitted over several meters using a simple coaxial cable. And that is practical. But every amplifier needs power, and that is the trick. We supply the integrated amplifier with power via the same cable so it can work. This is similar to phantom power for condenser microphones. The microphone only works with active phantom power. And the same applies here. The device only outputs a signal when the supply voltage is activated. How much current the sensor requires depends on the sensor. The datasheet quotes 2 mA to 20 mA. I would start with 2 mA. That saves power and battery. If this is not enough, I can increase it to 4 mA. But most sensors get by with 2 mA. Let me show you. I switch on ICP. Now you can see a voltage reflection on the channel. That's where the coupling capacitor integrated in this Quadriga 3 charges up. We need this to split off the measurement signal from the sensor. After 1 to 2 seconds, we are ready to measure. This transient response also occurs when the sensor is reconnected. See? And this is normal and needed. ICP is therefore a constant current source which is now cleverly limited to a maximum open circuit voltage. Here, good 24 volts. Approximately in the middle, the amplifier in the sensor now supplies a DC voltage, so-called bias voltage. Here, 12 volts. The incoming signal is superimposed on this DC voltage as an AC voltage change. So the signal moves maybe between 2 and 22 volts. 12 volts corresponds to the measurement signal of 0. Plus minus goes up down. In this way, we have the wanted signal and supply current on one line. But be careful, this offset messes up the dynamic resolution during recording. For this reason, the superimposed signal is first applied to a coupling capacitor at the front end, the one that was initially charged. This now removes this offset again like a high-pass filter, so that the pure measurement signal is sampled around 0 with full dynamic range. In the Quadriga 3, the used capacitor size can even be selected for the relevant frequency range. Should every DC component below 2 Hz or everything below 22 Hz be removed? These low frequencies, which are rarely relevant in acoustics, can often mess up your measurement. I only want to evaluate the audible and perceptible range. So let's get rid of the deflections that don't interest me before we sample the data. Alternatively, I can even switch off the capacitor completely and measure the full DC component. The mode is indicated by a violet diode. Now that is something for experts. Then I can also use the front end to record frequencies below 1 Hz with the full measuring range, for example tilting and rolling movements. With these setting options, we get everything out of an ICP sensor. If this was helpful for you, just leave a like, and if you have any more questions about professional measurement equipment, just get in contact with us.